Turbo lag and turbo overboost are two shortcomings addressed by the invention of the VGT, variable geometry turbocharger. When an engine starts or operates at low RPMs, the volume and pressure of the exhaust gas will be low. To efficiently spin the turbine using this low volume of smoke, special vanes are provided around the turbine. How VGT reduces turbo lag. The engine control unit, ECU, controls these vanes. When there's a low volume of exhaust gas, these vanes reduce the area through which the exhaust gas enters the turbine. This helps to direct the exhaust gas to hit the outermost edge of the turbine. For example, if you partially cover a flowing water pipe with your finger, reducing the area where the water exits, even if the water volume is low, its speed can be increased. The same happens with VGT. The vanes reduce the size of the opening where the exhaust gas enters to spin the turbine, thereby increasing the speed of the exhaust gas. Furthermore, because these vanes are positioned at a specific angle, the exhaust gas strikes the turbine wheel at its outermost point, furthest from the central point. For example, if you try to spin a bicycle wheel by applying force very close to its central point, you'll need more force. However, if you apply force much further away from the central point, you can spin the wheel with less force. This is because torque increases with the distance from the central point. The same principle applies here. The exhaust gas strikes the turbine at its outermost point, furthest from the central point, allowing even the low force of the exhaust gas to efficiently spin the turbine. This effectively reduces turbo lag. How VGT prevents overboost. When the engine operates at high speeds, the volume and pressure of the exhaust gas will be higher. If this is used to spin the turbine speed might become higher than required, leading to back pressure and potential damage to the turbo, overboost. To prevent this, the vanes are adjusted in the opposite way. That is, they increase the area through which the exhaust gas enters to spin the turbine. This in turn reduces the speed of the exhaust gas. Also, because these vanes are positioned at a specific angle, the smoke strikes the turbine closer to its center. As mentioned in the bicycle wheel example, applying force closer to the center requires more force. Here, even though the volume and pressure of the exhaust gas are high, it can be used to spin the turbine in a controlled manner. Thus, the vanes around the turbine are adjusted by the engine control unit according to the engine speed and load, thereby increasing and controlling the turbine speed. This makes VGT engines more efficient and responsive.